Yeah, in this lecture we are going to discuss another couple of techniques which are used in NDT, and that is radiography and dye penetrant test. So, again let me tell you, radiography and dye penetrant test, these are not online tests, and they are, of course, radiography, another word is the X-ray. It is very expensive also. So, this is not done real time, though there are portable X-ray units and so on, so forth. So, before we go into radiography, let me talk about this dye penetrant test. So, they come under class of visual inspection. Well, let me tell you, even as a condition monitoring engineer or a maintenance engineer, nothing must escape our sensory system, be it what we hear, what we see, maybe what we feel and so on, okay, what we smell. Okay. So, a human being is a very good system in terms of sensing because of the sensitive human organs. But so visual inspection also is a good tool for knowing the condition of a machine. Of course, when we talked about CBM, I did mention that to know the condition of a machine, the machine has to be living or running, okay, or operating. But in such cases, when you talk about certain NDT testing techniques, the machine has been produced and then we do a quality inspection, or machine is in the shop floor, we inspect. Okay. So, visual inspection can help us for inspecting corrosion, large cracks. So, when I say large cracks, the cracks are pretty big, so that human eye can see them. But let me tell you, it is already too late. Okay. So, when on the surface a very small crack occurs, technique vision based systems can be used. Vision based systems could be camera based or could be because our naked eye we cannot see such micro cracks. You would have heard of doctors doing surgery assisted by cameras. Inspection of internals of pipelines by robot based cameras, okay, or what we have also what is known as boroscope. Okay. Surgery we have endoscopes, etc., etc. But in many mechanical production facilities, you will see, for example, a cylinder block which has been casted. Okay. This is a cylinder block, a single cylinder block. Suppose a crack has occurred So, what is going to happen? See, when a piston or the connecting rod which is moving inside this, okay, and they move under pressure and so on. So, there is a lot of gas pressure, and then of course, there are water jackets and so on. So, a crack, if it occurs because of exposure to high temperatures and high pressures, the gas or the fluid may leak out. So, this could be because of a bad casting. So, one has to be careful to ensure that the quality of casting is good. So, to detection of such micro cracks is not possible by naked eyes. So, rather people use a fluorescent penetrant or a dye like you see in this figure here. This is a connecting rod, okay, maybe after forging it has been machined, and then you will see that if we put a dye on the surface, because of the surface tension and the crack, the material dye is going to get deposited here on the surface, and under a fluorescent light this is going to glow. Okay. So, very easily under a fluorescent light. So, basically you have this material, the component sprayed with a dye, and then you see under a fluorescent light. So, any surface cracks which is there, they will start to glow. So, this is a very quick way of inspecting rather than waiting for putting it in a machine and then measuring the vibration because of this crack. It is already too late. So, right in the production stage of components, maybe after a major overhaul and maintenance, people also do such checks and so on. Okay. So, some of the other techniques of visual inspection, I just go back to the slide here. See, the most common visual inspection tools include, other than our naked eye, is this fiber scopes, boroscopes, magnifying glasses and mirrors. And you would have heard of robotic crawlers, permit observation in hazardous or tight areas such as air ducts, reactors, pipelines. Okay. Portable video inspection units with zoom allows inspection of large tanks and vessels, railroad, tank cars, sewer lines. You would have seen, you would have heard many a times, accidents happen when the crew goes into the manhole for sewer line, and there is a big drain where there is here sewage. So, they give out lot of poisonous gases, maybe CO2, CO. So, if any crew goes in, they have to of course go with good breathing protection. But in such a cases, if I put a vision based system, a camera based system, so nowadays vision based system are becoming very popular even in CBM because of the drone technology, drones with cameras. Okay. People are monitoring walls in open cast mine, whether they are stability of walls, landslides have occurred or not. Okay. These are visual inspection with drones. having wireless transmission capability. And the future, this is going to be very popular, okay. With less human intervention, all these things can be done. So, now coming back, when these were not popular, people today even in the industry, they use robotic based large oil pipeline, okay. Whether any obstruction has occurred, etc. So, we can have a camera based system, okay, on a moving crawler. They can move self powered, or they can be dragged and so on. I remember some of my friends, who 20 years ago when they joined as engineers, when large pipelines were being welded, the diameter of maybe 1 meter and so on. They used to literally crawl with their helmets, with their lights and on, to inspect the weld quality from the inside. But technology today has changed. Now we have ultrasonics, we have X-rays and so on. So, visual inspection has given, so your dye penetrant test is another way to very quickly check in a production facility whether a surface crack has occurred or not. Sometimes a liquid with a high surface, let me tell you the entire process here. A liquid with high surface wetting characteristics is applied to the surface of the part and allowed time to seep into the surface, breaking defects. Okay. So, the excess liquid is then removed, you wipe it off, and a developer is applied, okay, and spread it on the surface where it can be seen. And visual inspection is the final step. The penetrant is used, is often loaded with an UV dye, and the inspection is subjected an UV light. So, very easily you can see, you put the liquid, remove the excess liquid, put a developer, and then spread it on a surface and see it under a light. But you will see this process itself is very time consuming. Nevertheless, in the industry people do it. We cannot take it for granted that our product has failed because of there was a surface crack. But today with the high resolution cameras available, high resolution cameras, even looking under infrared and mounted on drones and development of signal processing algorithms to improve image quality and data compression techniques. Used to reduce the quantity of data and then of course, Wi-Fi to transmit. So, you see in CBM, we started with maybe a stethoscope where people sense the vibration, and that was the technology people used in the 40s. And today, about 70-80 years, we have come up to a technology where sitting in a location, maybe in IIT Kharagpur, you can be remotely monitoring a gas turbine in Alaska or a pipeline in Alaska. So, this is all very easy and possible today. Okay. Now, another technique which I will talk about is radiography, or sometimes we know as X-rays. Okay. All of you must be familiar with the X-rays in the airport baggage scanning, or medical X-ray when you I have a broken bone. I hope nobody has that. So, doctor tells you to get an X-ray done. So, similar also will be used for the machine condition, what is there and what has happened. But mind you, I must tell you that these X-rays, let us look at the electromagnetic spectrum. They are all part of the electromagnetic spectrum. The speed of sound c is 3 × 10⁸ meters per second. We are familiar with the infrared signals which you used in thermography, radio waves as compared to microwaves, but then we have, as we increase the frequency, the energy content in these rays are very, very high. So, you would have seen gamma ray is used for surgery, etc. You can penetrate deep into materials. X-ray intensity can be increased so that they will penetrate the human flesh, and notice the difference in density when they come across a bone. And we just saw how ultraviolet lights are used, visible light of course in the wavelength from 4000 to 7000 angstroms. So, you can decide on the wavelength and frequency, and this is this X-ray which we want us to be careful. The radiation can come from an X-ray generator or a radioactive source. So, this X-rays can be used to penetrate into materials, and that is why it is helpful to find out if a foreign object has occurred. For example, I create a high electric potential between a cathode and an anode. Either I can have an X-ray generator, very, very high voltage, and this will create this X-rays which will fall on a surface, okay, and the energy is such that it will penetrate the sample. Now, if this sample or the test device has a defect or a foreign protrusion, they are all of different densities. You would have heard of maybe this is human flesh, and maybe this is a human bone. Of course, I am not drawing the whole human being here, but for the sake of discussion, human bone. Okay. Excuse my drawing because I have not drawn the entire person here. So, if I put this X-rays and then I have some sort of an image plane wherein this film is sensitive to X-rays, I can get an image of the bone. So, you can detect, and that is what is used for your detection of gold in a bag which is being smuggled in the airport X-ray scanners. So, because of the density difference, they can say there is some heavy metal, gold has a very high density compared to your normal clothes or whatever you have put in your suitcase. So, that is how this is used. A similar concept is used to find out whether there is a foreign element, whether there is a crack. So, this is what is used, and of course, nowadays this film is being replaced with digital images. And you would have heard of CAT scan. Okay. That is nothing but computer aided tomography. Okay. CAT scan of a human being. You by X-ray, you can get the entire image. Of course, with you can monitor it. A human being. Of course, this is how I have drawn a human being. You can do a scan, move the X-rays, and then get scanned images of the surfaces, and you can have a 3D generated or generated image. Okay. And they can be all digital also. So, in the film radiography, so what happens? A part is placed between the radiation source and a piece of film. Okay. So, this is my part, and there is a X-ray film, and there will be two amounts of exposure, okay, because of the density. So, less exposure and a thicker and more density will stop more of the radiations. So, it will just be the reverse. Okay. So, the film darkness will vary with the amount of radiation reaching the film through the test objects. So, more exposure and less exposure, top view of the developed film. So, of course, this in an industrial scenario is very time consuming, and nevertheless, particularly in boiler tubes, there is a lot of scale formation, as you know. Okay. So, this is my tube. Of course, nowadays portable X-ray generators are there, which you can carry to the site, but all these processes are expensive and you require a trained technician. So, X-ray head. Okay. Now, imagine if certain scales have formed, deposits are there. In fact, the deposits will be there entire throughout. And if you look at the X-ray images on a section, you can clearly see such formation. These are all solid. So, your original tube was this, no scales and internal scales. So, because of this internal scales, what happens? The area is reduced. So, the flow rate will reduce. So, periodically you can do, because see, let me tell you, in such a steam power plant, the boiler tubes would not vibrate, okay, other than it is a flow induced vibration because of turbulence, etc. That is a different story altogether, and the vibration is very insignificant. On top of it, it is definitely not convenient or not desirable to measure the vibrations in a boiler tube when the boiler is in operation. Okay. So, how do you know the quality of the boiler tube, how good it is? So, when the boiler is shut down, because there will be many such tubes, you can do X-ray of the critical units in a few sample points and see such scale formations are there. So, then it is a time maybe to cut this pipe out and replace with a new pipe. So, there are a lot of engineering applications of NDT techniques for product quality assessment. Like we have seen X-rays, of course, the visual inspection, and earlier we had discussed about ultrasonics as well. And then in the next class, we are going to discuss about eddy current, and also we will see about your of course, this could be dye penetrant. and then we will talk about acoustic emission. So, again just to recap, when I talked about CBM, I did mention about vibration, wear debris analysis, and then talked about motor current signature analysis, thermography, and then all these NDT techniques. So, today again vibration is the most prevalent technique, 70%, wear debris analysis 20%, okay. And these are actually the remaining 20% throughout the world. And I must tell you, because of our research at IIT Kharagpur on motor current signature analysis close to 2 decades ago, I will proudly say that we are the first in the world to come up with this MCSA technique to find out faults in mechanical systems by MCSA, and now we have a patent on it, and you can go to my website to know the details. So, MCSA is a technique which is fast coming up because of its convenience, and we will see later on some of the case studies where this has been applied. Okay. These are some of the radiographic images enclosure I will show you. You can very easily detect the defects in such places. Okay. Thank you.